Today's lesson is all about learning how we can randomly modulate some of the properties on our audio source, such as our sound's volume. We'll start by learning how to use the function that Unity's API provides for us to randomize a float variable, which we'll use to set our volume to. But once we've achieved this, we'll be building upon our script from the last lesson and creating our own modulation systems of different complexity and flexibility. So in this lesson and the next, we're also going to get more creative as well as we look at how there's usually more than one way to get your audio to do what you want it to. Now, before we get started, let's quickly clarify what we mean by modulation. In game audio, modulation simply refers to changing a property of your sound as it's played in a game, such as volume or pitch. Random modulation, therefore, means to randomly change a property of your sound. So the goal of this lesson is to take our power-up collection sound we implemented in the last lesson and randomly modulate both its volume and its pitch right as it's about to play, to add a small amount of variety to the sound. So the first thing we need is to get our power-up audio script open if it isn't already. So find one of your power-up objects in your scene, select it, find the script attached to it as a component in the Inspector tab, right-click it and click Edit Script. Okay, so we're going to start by randomizing the volume of our sound, but before we can do that, we need to access it. Just like how we can access our audio source's public functions, such as the play function, we can use the dot operator to access its public variables. And its volume is one of them. So in order to access and change it, we're going to write just before we tell our sound to play. We're going to take our audio source, follow it with the dot to access what's inside of it, and then write the variable or property that we're after, which is called volume. Remember that the terms property and variable pretty much mean the same thing in this context and are interchangeable, just like functions and methods are pretty much the same thing. So now that we have access to our audio source's volume, we can set a new value to it. But how do we tell our script to pick a random value to set it to? Well, Unity's API provides us with a public class called random that we can access just like the debug class. Then within that class, there is a public function called range, just like the public function log that was written inside the debug class. Now, just like how when we give data to the log function, it performs a specific task using that data, which is to display it for us in Unity, the range function will perform its own specific task. The range function takes two different float values and will then pick a random number between those two. So by setting the volume variable to the result of the range function, our sound will be randomly modulated between these two values. Now the first value you give it will be treated as the minimum value that can be selected, and the second will be treated as the maximum. And remember what we learnt about in our audio sources lesson, the volume ranges from 0 to 1. So with this in mind, let's tell the range function to pick a random number between 0.5 and 1. Remember to follow these numbers with the letter F, as this function requires float data, which as we know needs to have that F next to it for Unity to recognize it. Let's also be sure that the sound will be modulated by adding a debug.log function and using it to post the value of our audio source's volume in Unity's console tab. And with that, let's save our script and test it in our game. Before you actually play the game, make sure you've got your console tab nice and visible, as remember we're going to be checking it for our debug.log function to display the value of our audio source's volume. Okay, once you're inside of your game, drive one of the tanks over to a power-up, and we should see a number between 0.5 and 1 appear in the console tab. And we do. Now if we collect another one, we should also see a different number appear. And as expected, we do. Perfect. So using the range function, we now have a script that will modulate the volume of the sound that it plays. But whilst this system we've created does work, it's very basic and isn't customizable at all. The word system, by the way, when used in this context of a script that we build, is a generalized term that I'm using to talk about all of the individual parts to our script as they work together and interact with each other. Now, putting raw data into functions and custom systems like this with no way for the data to be adjusted without editing the script is sometimes referred to as hard coding. Hard coding isn't necessarily a bad thing to do, but it's usually more helpful to use public variables instead of raw data that we may need to change later. And when it comes to modulation, we're very likely to want to make adjustments to the values that we want to randomize our sounds by as we continue to implement the rest of our audio. So once you finish testing out your game, jump back into the Power Up audio script. To give ourselves control over these numbers, we're going to create 2 float variables and use them in their place. So at the top of our script, inside of our class, we're going to declare the first one by writing the data type we want to use and giving it a name. We'll call it modmin, short for modulation minimum. We'll then do the exact same thing, but this time we'll create a float variable to represent the maximum value that we wish our volume to be set to. Next, we simply replace the numbers we put into our range function with these variables, making sure to put the one that will hold the minimum value first, followed by the maximum. Now, the last thing we need to do is make sure that these variables appear in Unity's Inspector tab when editing this script as a component of a game object. Now, we could do that by using the public access modifier like we briefly did with our audio source in the first lesson of this module. But in general, it's actually better practice to instead make variables that you want to adjust and tweak private and instead use the serialize field attribute with it instead. Remember that this attribute also makes the variable editable in Unity without leaving the variable exposed to unwanted edits by other classes. Now, this probably won't mean a lot to you at your level of experience with Unity and C#, so don't worry about it too much for now. We will be looking more at interacting between different classes and scripts later on, but if you'd like to understand the difference between a public variable and a serialized field now, then I've provided a link to an explanation for you under this lesson. So now let's just quickly do the same for our other float variable. Here's a quick tip. When assigning an attribute to a variable, you can place the attribute before the variable, like I have done, or above it. It will still be recognized either way, so feel free to choose whichever you feel organizes your script better. Okay, now let's save our script and see our changes in Unity. Okay, so let's take a look at our Power Up audio component in the inspector of our Power Up object prefab. Now we can see the minimum and maximum variables we created. Let's set these to 0.5 and 1. And then let's save our prefab. Let's also make sure that these changes to the prefab and the objects in our scene were saved by leaving our prefab, selecting a Power Up object and checking the value of the variables are the same. If they are, then we can play our game and see if we like those settings. Okay, so if we collect a power up, we once again see that the volume was randomized in the console tab. But now, even whilst our game is running, we can go over to one of our objects and make a change to those settings if we didn't like how the modulation from the last one sounded. So maybe we might want to change these to 0.2 and say 0.5. Then if we drive over and collect the one we just changed, we can see and hear that our changes were applied, making testing and adjusting our modulation settings quick and easy. One more thing to note, however, changes made to variables during runtime in this way will be undone when the game ends, so if you like the changes that you made, it's important to remember them. It's also worth remembering that the changes made to the individual objects in our scene won't be applied to the prefab of those objects. If we want a change to be permanent across all of them, we'd need to adjust these variables whilst inspecting our component on the prefab. Okay, great, our script now has a bit of functionality to it and we're making progress. However, there are a few flaws with the method that we're using. For starters, there's nothing stopping us or someone else who's working on this game from accidentally setting the minimum variable value too high and above the maximum. This would force the range function to give us an error in Unity and prevent us from playing our game, because remember, the first value or variable that we feed it must be lower than the second. Another issue with this method is that, as we've already established, the volume field cannot be set any higher than 1 or any lower than 0. Yet there's nothing stopping our variables from exceeding these limits. Whilst this wouldn't give us an error or break our game in any way, we can make sure that our variables stick to this range and give us the intended results that we're after. Okay, so the way that we're going to fix these issues is by redesigning our script and the way in which we interact with it in the inspector. Right now, we've got two variables that can be used to set a minimum and a maximum to the range at which we can modulate our sound. But alternatively, we could create a new float variable to represent the size or the total amount of modulation we would like to apply to our volume. We could then take whatever value our volume is set to on the audio source and then add or subtract the size from it to find out what our minimum and maximum limits for our range function would need to be. So to do that, let's first remove our min and max modulation variables from our script, and then create a new serialized private float variable and call it mod size, short for modulation size. Now, to prevent this variable from being set any higher than 1 or lower than 0, we're going to use a new attribute, either on the line above or in front of the serialized field attribute, it doesn't matter which. We're going to write inside of 2 more squared brackets range with 2 regular brackets. And just like with our range function, we're going to give this attribute a min and a max value, which will be 0 and 1. This will now prevent us from being able to set the variable any higher or lower than this range inside Unity's Inspector tab. And you'll see how it does this later when we go back into Unity. Okay, so before we write out the rest of our script, here's what we're going to do with this new variable. As mentioned, we can take the size and work out the min and max values to give to our random.range function. To find the minimum, we'll take half of the modulation size and minus that from the volume of our audio source. So let's say, for example, that the volume was set to 0.5 and the modulation size was set to 0.4. We'd halve the size, which gives us 0.2, and minus that from 0.5, which would give us our minimum value of 0.3. We then do the same thing to work out our maximum value. We take the size of 0.4, halve it into 0.2, and then add that to the volume of 0.5, giving us a maximum value of 0.7. We then tell our random.range function to pick a number between 0.3 and 0.7, which we then set the audio source's volume to before the sound is played. So how do we write those calculations out into our script? Well, first we're going to need to declare a couple of variables inside the onTriggerEnter function when our player enters our trigger area. So before we use the random.range function, let's write float min semicolon and float max semicolon. These variables are going to hold the minimum and maximum values that we're about to calculate for us to then feed into the range function. Now, by creating variables inside of a function like this, we're sort of creating kind of temporary variables. Because variables declared within a function behave a little differently from regular variables, there's 2 main things you need to know about them. First, they can only be interacted with from within the function that they were declared in. So for example, we wouldn't be able to set a new value to the min variable from within the start function. If we tried to, Unity would give us an error as we can see by the red line underneath the word min. The second thing to know is that it's more efficient for our script and our game as a whole if we declare variables directly inside of functions rather than classes where we can. This is because function declared variables and the data that they hold only exist for as long as that function runs for, which we know is usually about the length of a single frame. Once the function has finished doing whatever it is that we told it to do, Unity will automatically delete and clear any data that is no longer needed, such as variables declared within them. Whereas variables declared directly within a class are held onto for as long as the class and the script it belongs to is active for in our game. So declaring variables inside of functions where you can is a good practice and habit to get into, as it means that the data it holds is only ever in use for as long as it is needed. Moving on, now that we have some variables, let's calculate the min and max limitations of our random modulation, starting with the minimum. Now, as we worked out earlier, to calculate our minimum, we want to start by taking whatever our audio source volume was set to. So let's write equals source dot volume. Next, we want to minus that number by half of whatever we set our modulation size to. So we will write minus modulation size divided by 2. Now, when writing mathematical equations out like this, it's important to know in which order our numbers will be calculated in, because Unity won't necessarily follow this equation from left to right. As a general rule, multiplication and division is always done before addition and subtraction. So the modulation size value will be divided by 2 before the result of that is then subtracted from the volume of our audio source. And that's exactly what we want to happen, so we know that we can leave our mathematics as it is. In the future, when making your own calculations in your script, you may want to remind yourself which order Unity will follow your calculations in. So underneath this lesson, you'll find an online guide that explains the order in which most mathematicians and computer programs, such as Unity, solve equations. Now, we need to write a similar equation to work out our maximum value. This time, we're going to take the value of our volume and add half of the modulation size. And now that we've calculated our new range for our modulation, let's take the min and max variables and feed them into our range function. So let's replace mod min with min and mod max with max. Now, to make sure that our calculations will produce the correct results for us, let's go to our debug.log function and let's change it to tell us the values of the min and max variables after they have been calculated. So let's write the name of our first variable, which was min. Let's then separate it from the next variable we're about to write by adding a plus sign, then within quotation marks, making a space, and finally let's include our second variable, max. We can also include the random value that our function will pick between these two variables by making another space and then writing source.volume. Okay, take some time now to add all of that into your script. Once you have, let's save our script and test it over in Unity. So before we test our game, let's make our way over to the prefab of our power-up object and set a value for the modulation size variable for our script to apply to all of the copies of this object in our game. Now notice how instead of a box to fill in, we have a slider that ranges from 0 to 1. The reason why is because of the range attribute we added to our variable earlier. Not only does it prevent us from exceeding the limits that we give it, but it also allows us to interact with our variable with a slider rather than typing a number into a box. Okay, so now we want to test to see if our script will produce the correct min and max values for us using the equations that we gave it. So to start, we will set our volume to about 0.7. Next, we'll scroll down to our script and we'll set the modulation size to 0.4. Now remember, Our script is going to take half of this 0.4, which is 0.2. It will then add that to the volume value of 0.7, giving us a maximum value of 0.9, and also minus it from 0.72, giving us a minimum of 0.5. The difference between 0.5 and 0.9 is 0.4, the size that we've set our modulation to. So now that we've made our changes and saved our prefab, let's play our game and drive one of our tanks into another power-up object. Okay, so if I drive into this power-up in front of me, we see the range that we predicted and told our script to calculate for, plus the random number between them that our function has decided to set our volume to. Excellent, we not only have a script that will modulate the volume of our audio source, but we've also looked at how we can take a simple script, design a bit more functionality for it, and then apply that design in code to improve it. Before you move on to the next lesson, feel free to go back over this lesson and enter your own values for the variables we created. Instead of just copying the numbers that I used, have a listen to how drastically you can create randomized volume modulation. Now, whilst the basics behind randomly modulating audio properties has been covered, we're not yet finished with modulation. In the next lesson, we're going to be expanding this script even further. There's still one or two flaws with this system that a better designed script can fix, plus we'll also look at modulating the pitch of our audio too. And whilst you could almost certainly add pitch modulation to our script using what we've discussed in this lesson right now, we'll be doing it in a way that turns our script into more of a modulation calculator, where it can take any numerical property on our audio source and randomly modulate its value. Now, if you need more resources to help you understand what we've covered in this lesson, you'll find some additional ones underneath this video. But you'll also find a link to see all of the different stages of development our script went through today, as a way of recapping how it evolved throughout this lesson. So once you feel confident with what we discussed in this lesson, head on over to the next one.